Now let's take a look at how we would measure rotation with an Arduino. And one way you could do that is with a rotary encoder. Now, unlike a potentiometer, because many times people, when they're just starting out with electronics, think that this looks like a potentiometer, and it does. It has a similar form factor, but some things you'll notice that are very different is the pinout. Now, on this one, you'll see these little lugs right here. This is for snapping it into a board when you solder it in. I just bent them out because conveniently it plugs into a breadboard then. I can use it in the breadboard. But what I wanted to point out was the pins on it. Potentiometer has 3 pins, if you remember. One of them is ground, one of them is positive voltage, and there's a sweeper in there, and that is a variable resistor, and we measure the resistance. A rotary encoder actually measures where it is from its start point to where it's moved to. So I can continuously turn this forever. And the Arduino is able to understand whether it was turned forward or reverse. So similar to a volume knob, although a volume knob has a limit, many car radios, when you're tuning the channels now with digital stations, you can just turn forever. That's what this is like. A couple things to note before we hook it up. You can buy lots of different tops for them. This one has one of these kind of interesting little dial tops. I don't really like that one as much as I like this one here. It's kind of a nice little feel to it. And you can buy these caps based on the shaft diameter. Let's see, hopefully this goes on. There we go, that one's on there pretty good. This one's nice, has a nice rubber feel to it. So the difference with wiring it up compared to a potentiometer is you'll see one side has 3 pins and one side has 2. Well, the 2 are really easy to hook up because they're just like a button. In fact, when I press this, you can hopefully hear that a little bit. It is a button, so that's a select button, kind of nice feature. And then the other side has 3 pins. And basically with the Arduino, you hook each one of the outside pins to an interrupt pin on an Arduino. Now, what's an interrupt pin? That's a good question. An interrupt pin with Arduino is, we'll call it a high priority and a fast reading pin. On the Uno, there are 2 very specific interrupt pins. We'll look at that in the code. And what happens is if your Arduino code is running and all of a sudden it detects a state change on that pin from a high to a low of a digital pin, it will immediately stop and say, what's going on? I need to mark this. I need to write this down. I need to store this information in my memory. So with the 2 interrupt pins on here, and then the center pin is a ground, we're able to measure the 2 pins inside that are on a wheel. And that's a little easier to explain in a drawing. So let me grab a piece of paper and draw that out for you. Inside this rotary encoder, there's basically a wheel, and there are little pads all the way around the wheel. Maybe something like this. Probably a little bit better than that, right? And these pads are metallic. And then if you look at this, there's 2 wires here. There are 2 pins in it, and we'll just, for argument's sake, let's say 1 pin sits here and 1 pin sits here. And these are the wires to the Arduino. So interrupt 1 and interrupt 2. And as this rotates either direction, the Arduino is able to sense whether one went high or low and which one went high or low first. So you can see if we turn this dial this way, this pin would go high, this one stays low, and as soon as this pin goes to high and this pin is high, we say, oh wow, we've actually turned clockwise, and we've turned clockwise 1 count. So if it were to turn this way, you can see if I turn this dial this way, this pin would go from low to high because it's making contact with this metal pad, and this one would go from high to low. So we know that since this one was triggered first, that we were turning the dial that way or counterclockwise. That's a very simple explanation of how this particular rotary encoder works. There are many different kinds. You can look them up online and get lots of more information. So let's go ahead and hook this up. And first I want to look at the code because I want to show you those interrupt pins. So I will just get this on the breadboard. And like I said before, these 2 are for the button. These 3 are for the encoder. So I'm going to just span the gap here and just kind of fit them in. And because I bent those 2 tabs up, you can see for prototyping purposes, this is great. I've got a nice button and I can just turn this. And really there's only going to be 3 wires to hook up. So I'll just grab a couple of wires and then let's jump into the code. There's a library, of course, because it's Arduino and we like to make things easy, so we use libraries. So let's load up Arduino software, and in include library, manage libraries, you can just type in Rotary, and you'll see there's an encoder right here. Mine's installed because, again, I test everything before I shoot a video. So if yours is not installed, you'll have a little button here that says Install. Once that's installed, you can go to File, Examples, and Encoder. Here it is. And we'll just go to Basic. And we'll close that up, and we'll look at the basic code. And we're going to take a quick look at the code. We're not going to dive in too much because that's not what this video series is all about. It's not purely code. It's about getting things done. And what we want to do is get a reading out of this potentiometer so that we can react with something else. We have the library, which we installed. And then if you look down here, change these two numbers to the pins connected to your encoder. Both pins have interrupts. So that's a good question. What pins have interrupts? So if I go to Arduino Uno interrupt pins, we'll just Google that really quick. And we go down here on the Arduino website, which is /en/reference/attach interrupt, but you can just Google it, it comes right up. The Uno that we're using, 328 based, digital pins 2 and 3 are the only two interrupts on an Uno. So we want to use those two pins because we'll get the best and most accurate measurement. Because remember, those interrupt pins, the Arduino is always making, like, it's almost on edge, just waiting to hear it, just waiting to see it go from high and low. So they're very, very fast to react. So we want to make sure we use those two. If you have a different board, you can see they're all listed here on the website. Close that out. So we said 2 and 3. So I'm going to put 2 and 3. For the interrupt pins. And the rest of the code literally prints. We're doing a basic test. It's holding a position and it's letting you know whether the position has changed or not. So let's wire it up. We're going to skip the button for now. That's a little too basic for this video, but I've got the one outside pin connected to pin 2. I've got the other outside pin connected to pin 3. And I've got the middle pin connected to ground. Let's go ahead and plug this in. Everything's been identified. Let's upload it. There we go, we're uploading. Done uploading. We'll go back over here, open up my serial monitor. And you can see it says Basic Encoder Test 0. Now, if I turn this, you'll see it jumps by 4 each time I turn it. I can turn it back the other way and go this way. And what's really cool about Rotary Encoders is that the way the software works is it just keeps adding and adding and adding. Look, I'm already at 409. Now if I turn it counterclockwise, I can go all the way back down to 0. My original position when I hit reset.